Bismillahirrahmanirrahim. In our today's lecture, we will discuss about numericals of chapter number 6. Numerical number 6.1. A gas occupies 6 liter of volume at a pressure of 12 atm. 12 atm pressure पर गैस का जो वॉल्यूम था वो था 6 liter. What will be the volume of the gas if the pressure is increased by 2 atm? अगर प्रेशर को 2 atm और ज्यादा कर दिया जाए तो उसका वॉल्यूम कितना होगा? Assuming that the temperature remains constant, और हमने assume करना है कि जो टेम्परेचर है वो constant रहेगा. So given data, V1 is equal to 6 liter and P1 is equal to 12 atm. Further, V2 is equal to question mark and final pressure P2 is equal to P1 plus 2 atm because it is increased by 2 atm. So it is equal to 14 atm. Solution: as temperature is constant, so P1 V1 is equal to P2 V2. Separating V2, so V2 is equal to, by putting the values of P1, V1 and P2, it is equal to 5.14 liter. Numerical number 6.2. In a vacuum chamber which is connected to a cryogenic pump, pressure as low as 1 nanopascal being attained. एक वैक्यूम चैम्बर जो कि क्रायोजेनिक पंप से अटैच था, उसमें जो प्रेशर अटेन किया गया वो 1 नैनोपास्कल था. Calculate the number of molecules in 1 cubic meter vessel at this pressure and temperature of 300 Kelvin. 300 Kelvin टेम्परेचर पर और इसी सेम प्रेशर पर आप लोग नंबर ऑफ मॉलिक्यूल्स फाइंड करो अगर वेसल का जो वॉल्यूम है वो 1 क्यूबिक मीटर हो तो. गिवन डाटा P is equal to 1 nanopascal which is equal to 1 into 10 to the power minus 9 pascal. V is equal to 1 cubic meter. T is equal to 300 Kelvin and N is equal to question mark. Solution: as we know that PV is equal to N kBT, separate it for N, so it is equal to PV over kBT. Kb is the Boltzmann constant and its value is 1.38 into 10 to the power minus 23. By putting the values of P, V, Kb and T in this formula, we get N is equal to 2.14 into 10 to the power 11 molecules. Numerical number 6.3. A gas undergoes a thermodynamic process which it absorbs 500 joule of heat energy and performs 300 joule of work on its surroundings. एक गैस है जो कि थर्मोडायनामिक प्रोसेस से पास हुई और उसने जो हीट एब्जॉर्ब की वो थी 500 जूल और 300 जूल उसने वर्क डन किया सराउंडिंग पर. कैलकुलेट द चेंज इन इंटरनल एनर्जी ऑफ द गैस. वी हैव टू फाइंड द चेंज इन इंटरनल एनर्जी ऑफ द गैस. गिवन डाटा, heat absorbs 500 joule and work done is equal to 300 joule. We have to find the change in internal energy. So solution: according to first law of thermodynamics, Q is equal to delta U plus W. Separate it for delta U, so delta U is equal to Q minus W. By putting the values of Q and W, it becomes equal to 200 joule. Numerical number 6.4. A Carnot engine is operating between a high temperature reservoir at 600 Kelvin and low temperature reservoir at 300 Kelvin. Calculate the maximum possible efficiency. We have to find the maximum possible efficiency and the amount of work output if the engine absorbs 500 joule of heat from the high temperature reservoir. अगर हमारे पास हाई टेम्परेचर रिजर्वायर से जो सिस्टम है 500 जूल हीट को एब्जॉर्ब करे तो तब हम लोगों ने अमाउंट ऑफ वर्क डन को भी कैलकुलेट करना है. सो गिवन डाटा, T1 is equal to 600 Kelvin and T2 is equal to 300 Kelvin. Eta is equal to question mark, and if Q1 is equal to 500 joule, then W is equal to question mark. Solution: as eta is equal to 1 minus T2 over T1, by putting the values of T2 and T1, it becomes equal to 0.5 and percentage efficiency is equal to 50%. Now eta is equal to W over Q, means output over input. Separate it for W. W is equal to eta into Q. By putting the values of eta and Q, it becomes equal to 250 joule. Numerical number 6.5. A refrigerator extracts 1200 joule of heat from the interior and release 1800 joule of heat to the surrounding environment, the hot reservoir. During each cycle, calculate the work input required per cycle and the coefficient of the performance of the refrigerator. We have to find the work input and coefficient of performance. So, given data, QC is equal to 1200 joule and QH is equal to 1800 joule. We have to find work is equal to question mark and coefficient of performance means E is equal to question mark. Solution: as for refrigerator, W is equal to QH minus QC. By putting the values in this formula, it becomes equal to 600 joule. Further, we have to find the coefficient of performance. So, COP is equal to E is equal to QC over W. By putting the values of QC and W in this formula, it becomes equal to 2. Numerical number 6.6. Calculate the entropy change when 1 mole of ice at 0 degrees Celsius melts to form a liquid water at the same temperature. We have to find the entropy change for 1 mole of ice at 0 degree Celsius. Heat of fusion of ice per mole is 6.01 into 10 की power 3 joule और heat of fusion हमें given है जो कि 6.01 into 10 की power 3 joule है. Given data, N is equal to 1, that is the number of molecules. T is equal to 0 degree Celsius and 273 Kelvin. LF is equal to 6.01 into 10 की power 3 joule, that is given. Delta is equal to question mark. Solution: delta is equal to delta Q over T. By putting the formula of delta Q and by putting the values of N, LF and T in this formula, it becomes equal to 22 joule per Kelvin. Numerical number 6.7. A gas occupies 400 milliliter at 20 degrees Celsius. What volume will it occupy at 80 degrees Celsius? 20 डिग्री सेल्सियस पर उसका जो वॉल्यूम था वो 400 मिलीलीटर था. वो कहते हैं उसका वॉल्यूम कितना होगा 80 डिग्री सेल्सियस पर, assuming constant pressure. So, given data, V1 is equal to 400 milliliter, T1 is equal to 20 degrees Celsius, which is 293 Kelvin, and V2 is equal to question mark, and T2 is equal to 80 degrees Celsius, that is 353 Kelvin. Solution: as pressure is constant, so V1 over T1 is equal to V2 over T2, that is the Charles law. So V2 is equal to V1 over T1 into T2. By putting the values of V1, T1 and T2 in this formula, it becomes equals to 481.91 milliliter, that is equal to 482 milliliter. Numerical number 8. A gas has a pressure of 2 atm at 300 Kelvin. What pressure will it have at 450 Kelvin assuming constant volume? एक गैस जिसका प्रेशर 2 atm है 300 Kelvin टेम्परेचर पर, उसका प्रेशर कितना होगा 450 Kelvin पर, assuming constant volume. वॉल्यूम को हम लोगों ने constant assume करना है. Given data, P1 is equal to 2 atm, T1 is equal to 300 Kelvin, T2 is equal to 450 Kelvin and P2 is equal to question mark. Solution: as volume is constant, so by using Gay-Lussac's law, P1 over T1 is equal to P2 over T2, separate it for P2, and by putting the values of P1, T1 and T2, it becomes equals to 3 atm. This is the right answer.